Good day, my beloved learners. I am Awafarei Tabanyeza, the SES for Technical Mathematics. Then today I'll be introducing this new topic in you, which is integration. Then, whenever you are dealing with this, with this integration, we shall be trying to look on the lesson outcomes of this. That now, by the end of the session, what is it that you are supposed to know? Then I'll say that now we have got 4 aspects that we shall be much more interested on. Where one, it's your understanding the concept of integration itself, which we said now, this is the converse of differentiation that you have already done during term 1, or we can say now integration, it's the reverse process of differentiation, where we'll also try to look at it. Then, and also the other part, we've talked of integration, we shall also be talking of it as a summation of function, which is definite integral. But for the lesson of today, we are only going to focus on the indefinite integral, where I'm going to explain in detail what indefinite integral is. Then the second objective, it's you must be able to apply the standard integrals of integration, or the converse of differentiation, wherein now we should be looking at 3 standard functions, where we are going to enlist those standard functions of integrals. Then the third outcome, it is now where I'll be showing you those are standard integrals, where 3.1 is if your k, which is a constant, multiplied by x to the exponent of n, but where now that n should be a real number, and you should ensure that now your value of n must not be equals to -1. And your second standard function, it's your k over x. Then where lastly, it will be your k of a to the exponent of n of x. In both of these two, ensure that now your value of a must be greater or equals to 0, and your k and a are the element of real numbers. And lastly, then we shall be looking at how to integrate the polynomials, then where it will be consisting of either be the multiplications or the product of functions. Then we will come to that at the last part of our lesson. Then, in order for you to could understand this concept of integration, there are some basic concepts that you need to make sure that now you master all of them. Firstly, it's your exponential laws, then which becomes as the basics of understanding either you are dealing with your differentiation or you are also dealing with integration. Then we shall be referring to exponential laws like for any number to the exponent of 0, it's equals to 1. This is something basic that you need to understand. And you can also have like, if we have x to the exponent of -1, this can be written in a fractional form as 1 over x. These are some of the standard exponential form. Then, and beside the exponential laws, then this also should be coupled with the surds. You should know all the basic laws of how to simplify the surds. For example, if you are given square root of x, you must be able to know that now, then this must be changed into exponential form, and it can be written as x to the exponent of half. Then, of course, this one we said now normally is one of those simplest SAT. But then many times it becomes more complicated if you are given a SAT like cube root of x squared. Wherein now you have to change this from the SAT form into the exponential form. Then this will be your x to the exponent of 2 over 3. You must be able to could work with all these laws because they are the basics of integrations. You need them in order to understand the concept. Besides exponents and the SATs, you also need to know the basics of fractions. Reason being that now, whenever you are dealing with the integration, you firstly need to could change whatever that you're given into an exponential form. Then now it means that now even if it is given in a fractional form, make sure that that fraction is written in a simplified form. And then where now we have seen that many times it seems like many of the learners are challenged with the fractions. Then I'm just going to give maybe at least two few examples of other examples of the fractions. Say, for example, you are given 3 divided by x. Then, in this, can you be able to write or to determine the integral? Yes, you can, but then this must firstly be changed in its simplified form. Then by splitting the two fractions, then where you can split this as 3 divided by 1 multiplied by 1 over x, which is equals to 3, 1 over x. Because then if you remember one of the standard integrals, then it involves this, 1 over x. That is the reason why now we need to could ensure that now we change this 3 over x into this format. But then now, also you must remember, it is not each and every fraction that can be changed in the form of that 1 over x. Then now, how do we deal with it? Then here, let me give you an example like 2 divided by x squared. It's a fractional form. But is it possible for me to could change this 2 over x squared into the format that would give me 1 over x? No, it is not impossible. It's not possible. Then now, what I do in that regard, then still I must know how to split my fraction. Then which will be 2 divided by 1 multiplied by 1 over x squared. But now, this 1 over x squared, it is not in the same format as 1 over x. Then now, if it is not in that format, then now we must now try to change this to be in its simplified exponential form. Then, therefore, now, the whole fraction now will be 2x to the exponent of -2. Can you see it? Now, in this format, we can be able to apply the laws of, we can now be able to integrate this. Then, still on the fractions, sometimes you can be given some complicated fractions, like, say you are given x squared minus 4 divided by x plus 2. Can we be able to integrate this? No, firstly, simplify this fraction. Then now when you try to simplify it, look at both the numerator and the denominator and see as to whether, is it possible to could factorize it first? Because it is not every time that you'll be able to could factorize it. But then firstly, I've given you an example wherein we can be able to could factorize it. Like this can be simplified as x minus 2 into x plus 2, all divided by x plus 2. Wherein this can divide with this, and then now we will remain s with x minus 2. We have now simplified our fraction into x minus 2. In this format, we can now be able to integrate it. Then, but let me also give another type of the fraction wherein now you find that now you cannot factorize it. But if you cannot factorize it, what can we do in order to easily integrate it? Okay, say here you are given 5x cubed, say, plus x squared, all divided by x cubed. Can we be able to factorize it simply? No. Then now, in this case, if you find that now you cannot factorize it where you can get a solution, then now you need to be able to divide each term by your denominator. Then now you can now write this as 5x cubed divided by x cubed plus x squared divided by x cubed. Wherein now this and this will divide, then you'll remain with 5 plus. If we divide this here, we'll remain with 1, and then here we'll remain with x. Then therefore this will be 5 plus 1 over x. Wherein now in this simplified form, we can now be able to integrate this. Then another concept which is very important in understanding the concept of integration is the rule of differentiation. Like we have said earlier, that integration is the reverse process of differentiation. Then therefore now it means you must also be able to understand the concept of differentiation. Then which for now, then I can only remind you of the rule of differentiation, which says if f of x is equals to x to the exponent of n, then the derivative of f of x will be equals to nx to the exponent of n minus 1. Something very important that you need to understand. And also there are some other basic rules for difference, like the derivative of a constant is 0. Then you need to know that. Then lastly, in terms of the concept, it's the algebraic manipulation. Then through the experience, we found that now, many times during the examination, learners made the mistake, some very simple, silly mistakes, like your addition and multiplication, or where there is substitution, there is not correct substitution, and so forth. Then therefore now, ensure that now when you are in exam, be in a relaxed mode, then look everything that you're given, read the instruction properly, so that now you can also apply those simple algebraic skills. Thank you. Then, now, what is it that you need to know, or what is very important while you are you are integrating? One, simplify the fraction as far as possible before you do the integration. Like for example here, if you are given 5 divided by x to the exponent of 3, like I've initially indicated, firstly simplify this. This should be your 5 divided by 1 multiplied by 1 over x cubed. This is what you could do when you are not yet mastered what to do. But then if you have already mastered, it is not important to do this step. But you can just only proceed to the final solution there, which will be your 5x to the exponent of -3. And also those other examples are regarding the fractions that I've indicated earlier. Then, secondly, change all the surds to the exponential form. Like I've indicated earlier, then if you are given a surd, change it to be everything to be in the exponential form. I've already indicated this. We don't have to waste much of the time. And also, simplifying all the fractions. I've given you, or I've also explained this. Here, be very careful. If ever maybe there is a product of factors, like if you have your x minus 1 into your x plus 1, you cannot integrate it while it is in this format. Firstly, ensure that now you have simplified it and everything is written in its simplified exponential form, where this will give you x squared minus 1. Then the other example there is what I've already indicated earlier. Then the other important thing, very, very important, read the instruction. Follow what the examiner has required you to do. Then, like here, I've also tried to write it in red to emphasize. When you are integrating, leave your answer in exponential form. It is not necessary for you to convert it back to the surd form, if it was given the surd form. It is not important, unless instructed to do so by the examiner. The same applies is if ever there is a negative exponent. There is no need that for you on the final answer, then you must write your answer with a positive exponent. It is not important. It's a waste of time because at times there will be no mark allocation. If the examiner wants you to write your answer with a positive exponent, then a directive will be given on the instruction. Then therefore now, it is important for you to follow the instruction given by the examiner. Then I ensure that now, if you follow those guidelines, then I can guarantee you to get 70 to 100% on this section. Then, what is integration? Integration is defined as the reverse process of differentiation, or it is also called anti-differentiation. But then at our level, or in our contour caps, then let us focus only on, say, integration is defined as the reverse process of differentiation. Then I'll try to illustrate everything based on this case that I've put here. Okay. Then suppose you are given, let's say, if f of x is equals to 5x squared. That's the form that you are given. And then now, if we differentiate, or you are requested to differentiate, then now, as much as we are talking of differentiation, always remember your definition of differentiation, which says, if f of x is equals to x to the exponent of n. What does it mean? It means before you differentiate, always ensure that now your function is written in its lowest exponential form. That's the basic. Then, if it is already in the exponential form, then how do we find the derivative? Then always use the correct notation. The correct notation of the derivative is f prime of x, then which will be equals to n, x to the exponent of n minus 1. But then now, if we are going back to our example there. We said we are given f of x equals to 5x squared. What would be our derivative there? Our derivative of that will be equals to, we have got this 5, which is a constant. Then you leave that constant as it is, multiplied by, focus on the exponential form. Then, and if we are to apply this rule, now it means our power there is 2. Then x to the exponent of 2 minus 1. Then this will be 5 multiplied by 2 will give you 10x, because 2 minus 1 is equals to 1. Then now we can say the derivative of of 5x squared is equals to 10x, because you were applying this rule of differentiation. You're applying the rule of differentiation. But then now, on this cycle, we said now, integration is the reverse process of differentiation. Then now, in order to differentiate, we start from the answer that we derived from the process of differentiation, where in this case here, our answer here, we have our differentiated was 10x. And then now we said, this is the process. We come from the answer to the original question, which means we must make that now we're moving from this derivative to the original function. And how do we do it? We reverse the process. On the integration, on the process of differentiation, we have subtracted. But then when we deal with the integration, we add. And then basically we can now say then this f of x, this will be equals to the integral of this, which is equals to 10x, and then we also add that variable of integration. But then the rule of which, although we are still going to explain it further, we can say then the integral of x to the exponent of n dx will be equals to this will be equals to x to the exponent of n plus 1, all divided by n plus 1. And then now, if we are to go back now to what we are saying here, the derivative of f of x is equals to 10 of x. Then now, how do we go back to the original? We apply this rule here. Then, wherein we said now, if there was a constant, you keep that constant as it is. Then where now we can say the integral of 10 of x dx will be equals to 10 integral, we take that 10 out, the integral of x dx, which will be equals to 10 multiplied by x. And then we said now with integration, we don't subtract, but we add, which will be n plus 1 divided by, in this case here, our n. In this case here, it's 1. Then therefore now it also means here, this will be equals to 1. Then it should be 1 plus 1. And this will give you 10. 1 plus 1 is 2. Then therefore now this will be equals to x squared over 2. Then 10 divided by 2 is equals to 5. Then therefore the answer will be 5x squared, which is where we have started from. Then it becomes the reverse process. Then now, what is very important for you is to understand the basic rule. If it is differentiation, know what is the rule of differentiation. If it is the integration, you must know the rules for integration. Then this here then is the very same process that I've been explaining that now. Then when talk of the integration reverses what was done by differentiation. The same applies differentiation, it will be the reverse process. Then this everything is what I've explained here on this board. Then just a sort of a revision or a rewind of what we've done in terms of the differentiation. We said now in differentiation, the derivative of y is the function of x, which is written as if you are given y is equal to x squared, then therefore now its derivative, which can be written in using different notations. But in this case here, I prefer to use dy by dx. Then where, if we apply that rule of differentiation that I've explained earlier, we said now the derivative of x squared will be equal to 2x. But then what is very key for you is to understand the meaning. The meaning here. It's saying here, if it is written as y is equal to x squared, and which is then dy, that its derivative will be dy by dx equals to x. We are saying y function is being differentiated with respect to x, where dx indicates with respect to x. But then here, let me also emphasize, it is not always where dx will be used. For example, at times, you can be given, it can be in terms of d of t, d of m, which means you are differentiating in terms of t, or we are differentiating in terms of m. Then therefore now, don't always memorize that now always it will be d by x. No. Then any variable can be used. Then, now, if now we are to start now or to introduce formally the integration, or like I said, we've got two types. We have indefinite integral, and we also have got the definite integral. But for this lesson, we are only going to focus on the indefinite integral. Then now, let me write this. Integral of 10x dx equals to 5x squared plus c, like I've explained earlier. What is very important, you need to understand the language, the notation, because like we know that now mathematics is a very special subject with its own language. Then therefore now, we must use the language which is appropriate for the integration. Like here, we have got this symbol, which is sort of an S. What does this S mean? This is your symbol for integration. It's your symbol for integration. To show that now, we are going to integrate 10 of x in terms of x. And then the function that we are going to integrate, which in this case here is your 10x. We refer to it as integrand. This is the function which is going to be integrated. But then we are integrating 10 of x in terms of which variable? Then we are integrating, yes, in terms of the variable dx, where we said now this dx, it's your variable, it's your integration variable. And the rule that now if we're dealing with the indefinite integral, always remember to add the arbitrary constant, then of which we refer to it as the constant of integration. this variable c. Always it must be added. Don't lose any mark by omitting the c. Always you must add it. Then the whole answer here is the one that we'll be referring to as your indefinite integral. Then therefore now, my beloved learners, please understand each part, each symbol, each notation. Then therefore now, in that situation, you won't lose not even a single mark. Then, now, let's come now to the core lesson of this integration. Then, in order for you to understand, then each house has got its own rules that we need to follow. Then now, here on indefinite integral, we have got 5 basic rules that we are going to focus. There might be many, but here, then we are going to focus on what is prescribed on our examination guideline and our CAPS document. That's where our focus will be. Then, I said now we are going to focus on the 5 rules. The first one is what we call the power rule, which is the core definition of integration, which is your integral of x to the exponent of n dx. We said with integration is the reverse process of differentiation, where we said by differentiation, we subtract from n. But in terms of integration, we add 1 to the value of n. Then now here, this will be, your integral will be equals to x to the exponent of n plus 1 divided by n plus 1. But always remember to add the arbitrary constant c. Then we'll set plus c. But the other important thing here, immediately when we write this formula, we are now ending up in a fraction. And whenever we are dealing with a fraction, for the fraction to be valid, or for the function to be valid, ensure that now your denominator must not be equal to 0. Your denominator must not be equal to 0. And when you look on our denominator here, it is n plus 1. Then, in order for us to avoid the denominator to be equal to 0, which means now we must say your value of n must never be equal to negative 1. Because if we have our n to be negative 1, we are going to have negative 1 plus 1, which will give you 0. And then the whole thing becomes undefined. Then you must always keep that in mind. Then, besides the power rule, the other very important rule is your rule of the constant rule. Your constant rule. Then here, there are 2 examples here, and then here, be very, very careful. Then now, we have got the first one there, which is the integral of k dx, and wherein we say, this k is a constant. But at the same time, we are saying here, we are integrating in terms of x. Then, but if we take this k out as the constant, it means we're going to have k integral of dx. But it seems like as if here, there is nothing to be integrated, and which is not. That means here there is 1. Because 1 multiplied by, or any number multiplied by 1 is equal to that number. But then now here, remember we are to integrate in terms of x. But here we don't have our integrand here does not have that x. It means now we must introduce that x, which is not there. How do we introduce it? Remember the exponential laws that we said x to the exponent of 0 equals to 1. That rule must be applied here. Then now we can say here, this is k integral of x to the exponent of 0, which is to be integrated in terms of x. Now, at least now we've got the variable x. If now we've got the variable x, now we can apply the rule, the power rule that we've learned earlier there. Now, we can say now this will be equals to k integral of, remember then if we're adding, this will be 0 plus 1 divided by 0 plus 1. Then now this will be now equals to the, it's x to the power of 0 dx. Then now your answer will be kx plus c. Kx plus c. Because this one, this x here is coming from there, which will be your, this will be x to the exponent of 1 over 1, which is equals to x. That is where now this x is coming from. That is very important. Then everything here is coming from that rule, the exponential law that we have learned from the lower grades. Here also it must be applied. Then, but still on the constant rule, we also have another type of pattern that can come, that can arise. Then here we have, say, the integral of k f of x equals to this is equals to k integral of f of x dx. Then here, let's give an example of, here you are given the integral of 5x dx. How do we differentiate this? Or even say, you can say this is 5x squared. How do we differentiate it? Remember always, the constant, you can take it out. Then this will be equals to 5 multiplied by, now you have to integrate. Okay, you can say this is 5 integral of x squared dx. Then which will be equals to 5. Remember, at this time, I should think you have already mastered the power rule. It is no longer important for you to rewrite those simple steps. You can just go straight. Then this will be the integral of x squared will be your x to the power of 3 divided by 3 plus c, which can be written as 5 over 3 x to the power of 3 plus c. That is how you can apply the second example of the constant rule. Then another rule, which is very important, is what we call the logarithmic rule. Where the logarithmic rule, it applies wherein now you have this value of where your integrand is written in the form of 1 over x and nothing else, 1 over x. In that case, if you have got the integral of 1 over x, then this will be equals to ln, of which this ln we call it, it's a logarithm, but in our language we said now we call it as ln x plus the arbitrary constant c. Then what does it mean? Then now whenever you are given a function, say for example here you are given the integral of x to the exponent of -1 dx. Yes, it is already in the exponential form. Then you don't have to start by applying your power rule. Firstly, check as to whether can you be able to change this x to the exponent of -1 into 1 over x by applying the rule of saying x to the exponent of -1 is equals to 1 over x. your loss of exponents. Then yes, in this case, we can change this. It means now this can be written as the integral of 1 over x dx. Then when now that rule applies, which will be now the integral of 1 over x is equal to ln x plus c. I hope we are understanding each other. Check first whether is it written in the power form, but even if it is the power form, can we apply the power rule directly, or can we change it into that exponential form? Then let me also give another example on the very same rule here. Then say you are given integral of 2 over x dx. Is the fractional form. Can I apply the power rule directly here? No. But then I can take the constant out here. Then this can be changed as 2 integral of 1 over x dx. Then, wherein now we know that now, then the integral of 1 over x dx is equal to your ln of x. Then now this will be equal to 2 ln x plus c. There we go. Straightforward, ne? Yes. Then, from the exponential rule, from the logarithmic rule, our next rule is the exponential rule, wherein it says if you are given the integral of k a to the exponent of nx dx, then the integral of this will be your k, it will be your k, and this whole function here, which is to be integrated, which is in the exponential form, your a to the exponent of nx, all divided by n ln a. And always remember, we must add our arbitrary constant c. Then, what is it that is so key, or very important, in order to make that now you get full marks on this exponential rule? Firstly, on what you are given, be able to could identify your value of n and your value of a. Those are very key if you are to apply the exponential rule. Identify your value of n and your value of a. For example, suppose you are given the integral of 3 to the exponent of 2x dx. Before you apply the rule, firstly identify what is your value of n and what is your value of a. Where now, from that expression, you can see that now your value of n is your coefficient of x. Your value of n is your coefficient of x. Then now, on this example here, our value of n is equal to 2. And our value of a is equal to 3. If you can identify this, it becomes so easy for you to could get the answer. Then now, we said the integral of this, your numerator becomes your integrand as it is. That's very simple. Where your integrand here is 3 to the exponent of 2x divided by, according to the rule, it should be n ln of a. Then where our value of n here, we are saying it's 2. Then this will be 2 ln, our value of a is 3. Here you get your full 2 or 3 marks. as long as you understand on a function that now is identify the rule itself and what are the components of that rule, and identify those components before you could proceed with your integration process. Then lastly, is the sum and the difference rule. That is, if we are to integrate the polynomial, then which can be either the sum or the difference. But we said now, if we're given the f of x, you are integrating f of x plus g of x. Here there is the sum of two functions, f of x and g of x. But then now to integrate this now, you must split the two, which becomes now your integration of f of x dx plus the integral of gx. And remember always to add your arbitrary constant c. Please do that in order to minimize unnecessary penalties. Then, now here, there are some examples. I've given some sort of the typical exam questions, wherein now we shall be applying those rules that I've explained earlier. Where on rule number 1, it's where I was explaining, I've given where we are to apply the constant rule. Wherein now, when you try to look at this, it's integral of 3 dx. And our integrand is 3. But our 3 does not have x. But because here we're saying we are integrating in terms of x. But then that 3 does not have, which is a constant. Then therefore now we can say now, let's take that 3 out, which will be the integral of, if we remove, then also here there is 1 dx. And remember again the laws of exponents, where we can say this is 3 integral of, remember, 1 is equals to x to the exponent of 0. Always remember this exponential law. That's why initially I said now, please, there are these key concepts where through and through we are going to apply them. Then now it means here, 1 is equivalent to x to the exponent of 0 dx. Now because our function or our integrand is now in the power form, we can now apply the power rule. Then where this will be equals to 3x plus c. That's how it. Always remember the exponential laws. Remember the exponential laws. Let's look at another example wherein we are applying the power rule, where in this case here, we are given the integral of 2x dx. And if we are to take out our constant 2 out, here we have 2 integral of x dx, which now at least makes sense, that now we are integrating x in terms of x. Then now here, we can easily apply the power rule. But how to do that? Remember always that now, here, even if there is no power, if there is nothing, there is power of 1 there. Then now we have written the power form. Now we can apply the basic power rule. We can say now this will be 2x1 plus 1. Sorry, this 2 multiplied by x1 plus 1 divided by 1 plus 1 plus c. Wherein this will be equals to 2x squared over 2. Where this can divide, then now your answer is x squared plus c. And always don't forget to put that arbitrary constant c. Then now we have x squared plus c. Sorry, yes, it's x squared plus c. Then your answer is complete. let's look at another example. Then where this example is including then or is covering the scalar multiple. Then here you are required to integrate 4x cubed dx. Always where there's a constant, take out, factor out the constant. Then where this is going to give you 4 integrals of x cubed dx. For the integral of x cubed dx, then we're simply there. Our integrand is already written in its simplified exponential form, which becomes easy. Our life becomes so easy now. Then that will be just 4 multiplied by, now that we already know the power rule, there's no reason to rewrite those simplified then now. This can just be written as x to the exponent of 4 over 4 plus c. Then we can factor out this. Then now this will be equals to your x to the exponent of 4 plus c. What is very key in each? Firstly, check as to whether your integrand is it written in the simplified exponential form. Can you easily apply the power form? If it cannot be applied, then that way now you can look at other rules of integration. But then now, on this one for that now, already it was written in its simplified power form, which makes our life much more easier. Then let's look at the other example. Then where now here we are applying the addition or subtraction rule. You are given integral of x to the exponent of 7 plus 1 dx. One advice that I can give, wherein you are dealing with the integration of the polynomials, always put your integrand within the brackets so as not to confuse yourself. Put everything, your integrand, within the brackets first before you can integrate it. Then, okay, let's look there. We are having our integrand is x to the power of 7 plus 1. Then from that power rule, from that polynomial rule, we said now we can split this. We can say this is the integral of x to the power of 7 dx plus integration of 1 dx. Where from here, we have already mastered the power rule. Then we can say this is your x to the exponent of 8 over, there, always add your constant c. That will be x to the exponent of 8 divided by 8 plus, what is the integral of 1? It's x plus your arbitrary constant c. This is simple mostly if it is written in a linear form. There is nothing for you to do. But in some other case of the polynomials, you will find that now that integrand, it is a complex of different functions. You have got the functions, you have got the fractions, sometimes you have got the surds. And always remember, before you integrate, firstly try to check if everything is written in its lowest exponential form. Then let's speedily look at other example. Then we have got this integration of pi over x dx, pi over x. Then, this is very important. Always understand your constant. Please do not use the calculator to determine pi. Regard it as a constant, and you take as a constant as it is. If we are taking it, that pi as a constant, therefore that simply means we factor out that constant pi. That will be your pi integral of 1 over x dx. Then, now you look at this fraction. Is this fraction, can it be differentiated? Does it apply some of the rules that we have learned? Yes. This one, we can apply the rule of logarithm, wherein we know that the integral of 1 over x is equal to ln x. Then, therefore, now we can say the integral of pi over x dx will be equal to pi ln x plus c. Many times on these types of questions where there is that pi, learners are confused not knowing whether pi, is it a number or it's a constant? No, my beloved learners, that pi is a constant. And then take it as a constant as prescribed on our exam guideline or our policy document. Then let's move to another example, which is a fraction. But then on this one, integral of 1 over x to the exponent of 5 dx is a fraction. But then now, can we convert this 1 over x to the exponent of 5 into a logarithmic form? No, because when it's simplified now, it does not give us that 1 over x. And then now, if it does not give us that 1 over x, what do? Then now, try to change this into your power form. Then now, we can say this is the integral of x to the exponent of 5 dx. Then, from there now, you apply your power rule. Then, which will be equal to x to the exponent of negative 5. Here, let me also go back to the basics of those additions. Then, here we've got negative 5 plus 1 plus c. This is the case where earlier on when I was introducing the key concept, I've spoken about the algebraic manipulations. These are the type of the examples where learners become confused. Then some of them, they end up even not writing that negative which is given. Or even if they wrote it, then they make errors of additions. Some will write it as 6, which is not. This is just simple addition of negative 5 plus 1 is equal to negative 4. Then, therefore, this will be x to the exponent of negative 4 divided by negative 4. Then, plus c. And please leave it here unless instructed to do so. Earlier on the guidelines, I said, please don't change your answer into positive exponent unless required to do so. In this case here, yes, our answer has got negative 4. But an examiner in this case here never requested you to write your answer in the positive exponent. Then therefore now, don't give yourself extra job, which will be against your time to complete your exam paper. Then only respond to the instruction given by the examiner. Leave your answer on this form. Then, let's look at another example that involves, which is a polynomial. You are given the integral of integration of 15 square root of x dx. On our key concepts, I've spoken about the SATs that always ensure that now before you integrate, write your SATs in your simplified exponential form. And again here we have got the constant 15. In this case here, factor out that 15. Then we remain with the integral of square root of x. Then, but according to the rules of SATs, we can say this is the integral of x to the exponent of half dx. Now we have changed it from the SAT form to the exponential form. Now in this way here, if it is in a simplified exponential form, you can now apply the power rule. Then where now the answer will be 15 multiplied by x to the exponent of half plus 1 divided by half plus 1 plus c. Again here, this is where our learners, yourself as a learner, you also make mistakes of being unable to could add simple fractions. Yes, I understand. But then now here, if you know that you are struggling, with addition of the fractions, then don't be scared to use your gadgets, your calculator. You can use your calculator, and firstly, it's half, which will be, now you press the fraction button, where your fraction button there, on your numerator there is 1, on your denominator it's 2, then you press the forward button, now you said plus 1 equals to 3 over 2. Then now this will be 15 multiplied by x to the exponent of 3 over 2 divided by 3 over 2 plus c. You can come to the calculator only if you know that you are struggling in addition and subtractions of the fractions. Then don't be scared to use the calculator, so that now at least you can save your exam time. Then if you are to simplify everything here, this will be 10 x to the exponent of 3 over 2 plus c. Then the exponential integrals, fortunately, this example that I've made earlier, I've used the very same example. I said, now, firstly, understand the rule. Secondly, from the rule, identify your value of n and your value of a. Then you simplify it. Then let's look at the last example. Okay, then we are done with those examples. Then now, all those examples, they covered all those five basic rules of integration. From here now, when we have dealt with those, now you can do this practice exercise on your own. Do practice until you master each and every rule. On this practice exercise here, I've included all those five rules. Then, for the sake of time, then let us look now on the last one, but of which, fortunately, I think we have already explained how does it apply. But then I'll just give an example of this one, which is the integral of x squared plus 1 squared dx. This is a complex integrand. Then your integrand here, it's this. Before you find the integral, or you integrate it, simplify it here. And please, regardless of how advanced you are, don't use the methods that are not prescribed by your exam guideline, like the substitution rule. Then what we need here is to do the expansion, then which will be integral of x to the power of 4 plus 2x squared plus 1 dx after the expansion. Then after you've expanded this, now you can integrate each of these terms individually, which will give you x to the exponent of 5 over x to the exponent of 5, over 5. This will be x to the exponent of 5 over 5 plus 2 over 3 x to the power of 3 plus x plus your arbitrary constant. Then we're now, but the basic here is expand everything before you determine your integral. Then the next one, it's if ever your integrand is a sort of a fraction. Already I've also given this type of example where you are given 5x squared plus 1 over x. Always please put everything within brackets. From the split everything, this will be your 5x squared over x plus 1 over x. Still this within the brackets, dx. Now you can integrate, sorry, okay. Here you can simplify this. This will be 5x plus 1 over x. Then if you are to integrate, then this will be equals to your 5 over 2 x squared plus your ln x plus c. Then in all of these examples here, then you are applying the very same rules that you have learned. Then here I've also given you the practice exercises that where now you should be applying. Then you can look at example number 1. This shows here you need to expand x minus 1. It will be x squared, which will be x1 into x minus 1, which will give you x squared minus 2x plus 1. Then from there you integrate. You look at your example number 6. Is the product of factors. Then before integrate, multiply, remove those brackets. The same applies to number 7. Multiply out. Then, in conclusion, please, the bottom line in order to ensure maximum marks on this subtopic, 1, ensure that now you master all the standard integrals, like the integral of k, x to the exponent of n, that's the power rule. Secondly, the integral of 1 over x dx. And lastly, the exponential rule. Those 3, master them. But on top of that, you won't do anything unless you have mastered your laws of exponents. That's the basic when you are integrating the functions. Master your exponential rules. Thirdly, lastly, always, if you are dealing with the indefinite integral, you must remember to always add your arbitrary constant c. If you don't add c, then you can lose 1 mark from the possible marks. Lastly, use correct notations, because at times you find that now there is a mix of between the notations for differentiation and the notations for integration. Master, differentiate them. Know what is differentiation and know what is integration, and apply the notation where it is needed. That is the bottom line. But the lastly of everything, this section, it gives you about 15 marks out of 150, which is roughly 10%. To achieve this, you can only do that if you can practice, master the basics. Then we always preach, said, VUCA 60, then no. Whatever you can do, make that your minimum that you can get is at least 60% on each possible marks. This brings us to the end of this subtopic of indefinite integral. I can simply say, ndoliwa ngamanda. Thank you.